Okay, so last week I did this video on the channel about final, and I shared some thoughts about it. And believe it or not, I've been thinking about it some more over the weekend, and I wrote a blog post about it. And I wrote down some more thoughts about what inheritance is, because when we're talking about final, we're talking about preventing inheritance. So the meaning of inheritance becomes pretty important. And I feel like I covered some of my thoughts in this video, and there were like super interesting comments here as well. Go read through them if you want to. But I feel like there is something more to say about all of this. So in the weekend I wrote this blog post. It's a short one. I'll link it in the description and I will come back to this. But in this video I want to talk more about like the real meaning of inheritance. And I found this super interesting article. Well, not this one, but I mentioned this post in the past. It's also a great post by Larry, and he talks about how with the addition of traits, we don't really need abstract classes in PHP anymore. It's an old post, right? 2014 here. But I find that this post is also a bit confusing to follow. You really need to read it like 2 or 3 times to really grasp what's going on. But Larry mentions another post in his one, which was the inspiration for his original post. Anyway, I want to read like a small section from this one, because it's about Go and Rust, and like we're not programming Go and Rust, right? But I have the reader view enabled here because this is difficult to read. It's not properly styled. But he talks, or the writer, I don't know, talks about the many phases of inheritance. This is so eye-opening for me. Like, yeah, indeed, there are multiple ways of interpreting inheritance. And I already knew that. I wrote about it in the blog post over the weekend. But still, this author, they managed to like phrase it so well that it just clicks, you know. So let's read a small part of this post. Don't want to go through everything, but yeah, it's super interesting. So while inheritance is a core concept in object-oriented programming, it is not necessarily a well-defined concept. So I think we all agree on that. It always involves one thing getting some features by association with some previously defined things, but beyond that, languages differ. The thing is typically a class, but sometimes an interface, or even in prototype inheritance, an object that borrows some behavior and state from some prototypical object. And like JavaScript is an example of that, right? The features gained are usually fields and methods, but the extent to which the inheriting thing can modify, replace, or extend these features is quite variable. Inheriting from a single ancestor is common. Inheriting from multiple ancestors is sometimes possible, but it is even less well defined than single inheritance. Whether multiple inheritance really means anything useful, how it should be implemented, or how to approach the so-called diamond problem all lead to substantial divergence among approaches to inheritance. So yeah, multi-inheritance is like quite an important thing in my reasoning as well, but let's continue to read here. If we clear away these various peripheral details, important though they are, inheritance boils down to 2 or possibly 3 core concepts. It is the blurring of these concepts that is created by using one word, inheritance, which it would seem results in the wide variance among languages. And it is this blurring that is completely absent from Go and Rust. So yeah, he's talking about Go and Rust, right? And how they, like modern languages, take another approach to inheritance. And I do want to look a little bit at Rust later on. But let's put multi-inheritance aside for a second, and let's focus on these 3 concepts that are described here. 3 concepts that kind of differ, but all get the name inheritance. And actually, I want to only focus on 2 because data embedding isn't really something in PHP. So let's just scroll here to subtype polymorphism. So one of the 3 concepts, right? Subtype polymorphism is a core concept that is almost synonymous with object inheritance. Polymorphic code is code that works well with values from a range of different types. So for subtype polymorphism, the values types must be subtypes of some specified supertype. One of the best examples of this, which should be familiar to many, is the hierarchy of widgets provided by various graphical user interface libraries such as GTK Plus or Qt. I don't know if you know these libraries, but it doesn't really matter because like the words here, they'll be perfectly clear no matter whether you know these libraries or not. At the top of the hierarchy for GTK Plus is the GTK widget, which has several subtypes including GTK container and editable. The leaves of the hierarchy are the widgets that can be displayed, such as GTK entry and GTK radio button. So like the concrete classes are the things that can be displayed, right? GTK container is an ancestor of all widgets that can serve to group other widgets together in some way. So GTK hbox, vbox, which present a list of widgets in a horizontal or vertical arrangement. They are two subtypes of GTK container. So you can form this mental image, right? So we have a widget and it has a container subtype. It has, let's see here, entry and radio button as other subtypes, like inheritance, right? So, subtype polymorphism allows code that is written to handle a GTK container to work equally well with the subtypes hbox and vbox, right? So let's read that once again, because that's like the core of polymorphism here. Polymorphism allows code that is written to handle a GTK container to work equally well with the subtypes hbox and vbox, right? Now, subtype polymorphism can be very powerful and expressive, but is not without its problem. Fair enough. One of the classic examples that appear in the literature involves point and color point, and exactly how the latter can be made a subtype of the former, which intuitively seems obvious, but practically raises various issues. A real-world example of a problem with polymorphism can be seen with the GTK menu shell widget in the GTK Plus widget set. This widget is used to create a drop-down and pop-up menu. It does this in concert with the GTK menu item, which is a separate widget that displays a single item in a menu. GTK menu shell is declared as a subtype of GTK container, so that it can contain a collection of GTK menu items, and it can make use of the methods provided by the container to manage this collection. Now the difficulty arises, and this is a problem that I think many of us will recognize with subtype polymorphism. Difficulty arises because GTK menu shell is only allowed to contain GTK menu item widgets. No other sort of child widget is permitted. So while it is permitted to add a GTK button widget to a container, it is not permitted to add that same widget to a menu shell. So basically we created a subtype of our container called menu shell, but it doesn't actually give the same promises as container. So in a way, it is a subtype, but meanwhile there are some differences, and people decided to still extend the menu shell from the container because there is a lot of code that can be reused, is my guess. Now, if this restriction were to be encoded in the type system, GTK menu shell would not be a true subtype of GTK container, and it cannot be used in every place that GTK container could be used. True. Specifically, it cannot be the target of GTK container add my button. Anyway, the simple solution is to not encode the restriction in the type system. If the programmer tries to add a GTK button to a menu shell, that is called as a runtime error rather than a compile time error. To the pragmatist, this is a simple and effective solution. To the purist, it seems to defeat the whole reason we have static typing in the first place. I'm more in the purist camp, I would say, but still I also reckon that, there are some places where a simple inheritance chain, it's not gonna cut it, right? So you're gonna run into edge cases, and I think we've all been there. This example seems to give the flavor of subtype polymorphism quite nicely. It can express a lot of type relations as well, but there are plenty of relations it cannot express properly. Cases where you need to fall back on runtime type checking. As such, it can be a reason to praise inheritance, and it can be a reason to despise it. So that's interesting, right? Spoiler alert. When I talk about inheritance, I'm mostly talking about subtype polymorphism, right? Let's move to the second/third concept. And I think many people will recognize this as well. Using inheritance as a way to provide code reuse. The remaining concept in inheritance is code reuse. When one class inherits from another, it not only gets to include fields from that class and to appear to be a subtype of that class, but also gets access to the implementation of that class and can usually modify it in interesting ways. And this is like where the private protected debate starts to rise, right? Now, code reuse is of course quite possible without inheritance, as we had libraries long before we had objects. Doing it with inheritance seems to add an extra dimension. This comes from the fact that when some code in the parent class calls a particular method on the object, that method might have been replaced in the child object. This provides more control over the behavior of the code reused, and so can make code reuse more powerful. A similar thing can be achieved in a C-like language by explicitly passing function pointers to library functions as done with qsort. This code reuse might seem as though it is just the flip side of subtype inheritance, which was, after all, motivated by the value of using code from an ancestor to help implement a new class. In many cases, there is a real synergy between the two, but it's not universal. The classic examination of this issue is a paper by William Cook that examines the actual uses of inheritance in the Smalltalk AT class library. He found that the actual subtype hierarchy is quite different from the inheritance hierarchy. For this code base at least, subtypes and code reuse are quite different things. And so this I find interesting. Subtypes and code reuse are quite different things. I'm starting to understand more and more that I'm just having a very different expectation of what inheritance is about, and it doesn't align very well with what other developers use inheritance for. And now I'm not saying anything about which one is better or not. But it will be interesting to read further and see how languages like Rust, like modern languages, are solving this problem, and to think about how PHP can solve it as well. So let's take a look. As different languages have experimented with different perspectives on object-oriented programming, different attitudes to these 2 or 3 different phases have resulted in widely different implementations of inheritance. Possibly the place that shows this most clearly is multiple inheritance. When considering subtypes, multiple inheritance makes perfect sense, as it is easy to understand how one object can have 2 orthogonal sets of behaviors, which make it suitable to be a member of 2 supertypes. When considering implementation inheritance for code reuse, multiple inheritance doesn't make as much sense because the different ancestral implementations have more room to trip over each other. There's more room for collisions, right? It is probably for this reason that languages like Java only allow a single ancestor for regular inheritance, but allow inheritance of multiple interfaces, which provide subtyping without code reuse. And this is super interesting, right? This is the same in PHP. You can implement multiple interfaces, and there really isn't a problem if there are any collisions, because whether a method definition comes from interface A or B doesn't really matter. It will work the same for both interfaces. You still have to provide the implementation yourself. But if you have 2 abstract classes where you could extend from with 2 separate implementations for like the same method, then you run into problems. In general, having some confusion over the purpose of inheritance can easily result in confusion over the use of inheritance in the mind of the programmer. And this confusion can appear in different ways, but perhaps the most obvious is the choice between is a relationships and has a relationships. That is easy to find being discussed on the internet. Is a reflects subtyping, has a can provide code reuse. Which is really appropriate is not always obvious, particularly if the language uses the same syntax for both. So I once wrote a blog post about the difference between is a and has a. I actually don't really like that blog post anymore. But this is what Larry was talking about as well in his blog post, the difference between subtyping and code reuse. And now it seems to be like, if we look at PHP, there is a real problem. We have 2 separate ways of using inheritance. And we could debate whether there's one way better than the other. I know my preference, and I know other developers have their preference. And so discussions about things like final, they actually come down to this question: what's your preference of using inheritance? Like I said, it is interesting to see how languages like Rust have solved this issue. So let's continue to read for a little bit more. Having these three very different concepts all built into the one concept of inheritance can hardly fail to result in people developing very different understandings. It can equally be expected to result in people trying to find a way out of the mess. And this is just what we see in Go and Rust. While there are important differences, there are substantial similarities between the type systems of two languages. Both have the expected scalars in various sizes where appropriate. Both have structures and arrays and pointers and slices. Both have functions, closures and methods. But importantly, neither have classes. Neither Rust nor Go have classes. With inheritance largely gone, the primary tool for inheritance, the class, has had to go as well. The namespace control provided by classes is left to the package or module, and the data declarations are left up to the structures. The use of classes to store a collection of methods has partly been handed over to interfaces or traits in Rust, and have partly been discarded. So let's skip over the Go stuff because I wanted to look at what Rust does. Rust has a somewhat different syntax, which much the same effect. And the reason I'm skipping Go is because Rust feels way more close to PHP, basically. So in Rust, you say an implementation for point, and you add a method to that implementation, right? Is it an implementation? Yeah. A single implementation function can define multiple methods, but it is perfectly legal for a single type to have multiple implementation sections. So while an implementation may look like a class, it isn't really. You can have an implementation for point here, but another module can, is it module? I don't know that much of Rust, but yeah, module can provide another method into the same implementation for point. Now the receiver type on which the method operates does not need to be a structure. It can be any type, though it does need to have a name. You could even define methods for int, were it not for rules about method definitions being in the same package as a definition of the receiver type. Oh, interesting. So there are some rules there. Okay. So in both languages, methods have managed to escape from existing only in classes and can exist on their own, but they can be attached to a type, right? Every type can simply have some arbitrary collection of methods associated with it. There are times, though, when it is useful to collect methods together in groups. For this, Go provides interfaces and Rust provides traits. So this is what a trait looks like. These two constructs are extremely similar and are the closest either languages get to classes. They are, however, completely virtual. They don't contain any implementation or any fields for storing data, but that's not entirely true. We're going to read the Rust docs in a second. They are just sets of method signatures. Other concrete types can conform to an interface or trait, and functions or methods can declare parameters in terms of the interface of traits they must conform to. Okay, let's skip to here, exploring the new inheritance. Here we see the brave new world of inheritance. It is nothing more or less than simply sharing a collection of method signatures. It provides simple subtyping and doesn't even provide suggestions of code reuse or structure embedding. And you can see why I like this, because like the whole code reuse thing, it's gone. And you could say I'm just biased, but on the other hand, there are other ways to do code reuse, but there are no other ways to do subtyping. So I would say that subtyping does indeed get precedence over code reuse, right? Multiple inheritance is perfectly possible and has a simple, well-defined meaning. The diamond pattern has disappeared because implementations are not inherited. Each method needs to be explicitly implemented for each concrete type, so the question of conflicts between multiple inheritance paths simply does not arise. This requirement to explicitly implement every method for every concrete type may seem a little burdensome. Whether it is in practice is hard to determine without writing a substantial amount of code. I get that. An activity that current time constraints don't allow for this author. It certainly appears that the developers of both languages don't find it too burdensome, though each has introduced little shortcuts to reduce the burden somewhat. Okay, before moving on, let's read the Rust docs for traits, because they are pretty interesting as well. And there are similarities to PHP. So in Rust, you define a trait like this, public trait summary, and it has one method without an implementation. This would be like an abstract method within a trait in PHP, right? And then you can implement a trait on a type. So implement summary for news article. By the way, I just love Rust's syntax, but that aside. So in here you implement summarize for article. Here you implement summarize for tweet. And the thing with Rust traits is they can also have default implementations, just like PHP. Let's take a look here. Default implementations like this. So public trait summary, and here's the default implementation, and then you can overwrite it when, let's see here, when you need it. You can even call like other methods within the trait, so, like very similar. And so I reckon with these default implementations, there's still some problems with collisions, right? Because if you have multiple traits with the same method, both having a default implementation, then which one will you use? But that's the same problem in PHP, and we have solved that, right? We can, let's take a look here, PHP Trades. We can, resolution, yeah, there is conflict resolution here, right? You can use A and B and give them different names, or import them as an alias, you know, stuff like that. So in case of traits, like the solutions are already there in PHP as well, which is really cool. Okay, so back to inheritance and subtyping. The problem with PHP traits is that you cannot use them as types, because traits are basically just copy-paste during compile time. There is no information at runtime about whether a class used a trait or not, except if you start to rely on reflection. And so that's a problem compared to Rust, because we cannot use traits to the same extent as Rust does. We cannot use them for subtyping, so we cannot solve the inheritance problems with it. However, let's imagine that traits could be used for typing in PHP. And actually we already can, it just requires a little more work. We can use a trait and implement an interface. And that's exactly what I've been doing in Tempest as well. If you follow this channel, you might have like seen this pattern during some live streams. Tempest doesn't have abstract classes. We have interfaces, like the database model here, and we have is database model as a trait with the default implementation. Now these two are always used in tandem. They are always used together. Whenever a class implements a database model, it will also use this trait. And you can override methods if you want to. And you can even have this class implement other interfaces if you want to. I'm not saying that's good design, like multi-inheritance, but it is possible. It is possible in PHP. The only downside is you need to use a trait and then also implement the interface. And I'm like, wouldn't it be easier to do it like this? Trait. You see, this would basically solve all our problems, because like I said, the traits are copy-paste during compile time. They are copying over all these methods here. There is no technical limitation why they shouldn't be able to copy over the interface into this class. And then we have traits with typing, and basically the same way Rust does it, a little different, but it achieves the same goal. And you know, life is good. So yeah, I was talking about this in the final video as well. I think I'm gonna make an RFC for this. I believe it's been proposed in the past, so I need to read into that and see where the problems are. But there is a really good case to be made to use traits as types and for subtyping. So where does that leave us? Well, today nowhere, because we cannot do this, but it is like the main reason why I am preferring this approach over abstract classes. That is one thing. And going back to that blog post I wrote in over the weekend, you can read it. I'll leave a link in the description, of course. But I talked a little bit about how I feel like there's this difference in interpretations, the thing that the other blog post explained very well. And I was thinking about it and comparing inheritance with interfaces over the weekend. And I came up with a definition that kind of works for me. And I want to read that to you and just share your opinion about it in the comments, right? I want to use inheritance to reflect real-world relations, and I want to use interfaces to describe technical behavior. And I didn't have the right words maybe for this when I wrote this, but technical behavior here, I could also describe it as subtyping, basically. And as an example here, in my mind, user extends model, that doesn't make sense. A user isn't a model. Model is just a technical detail, something the code can do with this object. So in my mind, user shouldn't extend from model. It should implement model and then use a trait. But if we're talking about an admin user, that can extend user, because admin user is in fact a sub implementation, a child of the parent user. It is a user with some things changed or a little bit more added to it. So yeah, that's the definition I came up with. I'm not 100% happy with it, but yeah, I mean, I'm thinking about it. So one more thing to share before we end is there was this RFC last year, the Interface Default Methods RFC, and it turned the problem around. Instead of being able to type traits, it made it so that interfaces can contain default methods. But this RFC failed. Let me show you an example here. Yeah, over here. So both interfaces can provide a default implementation, and it's kind of similar to Rust traits, but it's approaching it from the other way. And there was a lot of pushback because like an interface should have no implementation. Basically, people were a little hesitant to add this in PHP. But I think doing it the other way around, having a trait implement an interface, and so getting rid of that little bit of overhead when you use a trait and implement an interface, which is a common pattern. I think there is something to say for that. So that's what I want to focus on. Let me know your thoughts in the comments. Looking forward to reading all of that. You can disagree with me. That's totally fine. Just share why in the comments. And while you're down there, leave a like. That helps me out. And I will see you in the next one. Okay? Bye-bye.